Today's lesson is the review for the Unit 8 test. Your Unit 8 test is going to have 11 questions, and I'm going to review some of them today, but not all of them. Let's go ahead and get started. Question number 1 is going to ask you to find the area of a parallelogram. It is going to say to include the correct units. Just a quick reminder that your bases and your heights need to be perpendicular to each other in the picture. And so let's go ahead and get started. The formula for the area of a parallelogram is base times height. So I'm going to use my highlighters to help me find the base and the height. The height might be a little bit easier to find because it should be a dashed line that is either inside or outside of the parallelogram, and it should have a 90-degree because it needs to be perpendicular. That means this is going to be my height. The base is going to be the side of the parallelogram that height is connected to. Well, that would be this one right here. So there's my base. I'm simply going to go ahead and multiply 13 times 8 for an answer of 104 feet squared, because that is what it is for area. Remember that you're never going to use the cubic unit. You're only going to use feet or feet squared. All right, moving on to question number 2. Find the area of the trapezoid. Here is my formula for the area of a trapezoid. Be sure to include the correct units in your answer. Remember, the height and the base need to be perpendicular. So the height is going to normally be a dashed line, and it has to have the 90 degrees. So that's going to be this one right here. Remember that base 1 and base 2 have to be the two parallel sides, plus the base has to be perpendicular to the height. So this is a base, and I'm going to go ahead and call it base 1. And so what side of the trapezoid is parallel to that? Well, it's got to be this one right here. So this is going to be my base 2. Now I can change those. I can change my base and my base 1 and my base 2. No big deal. But here we go. The height is 5. Let's see. I'm going to add 16 from the top plus 6 from the bottom. 16 plus 6 and 6 plus 16 are exactly the same thing, so it's okay. And then I'm going to pop that into my calculator, and I'm going to get 55 meters squared. I like the Desmos calculator personally myself, but Alex might provide a calculator for you as well. One thing I would draw your attention to, notice these two right here. That probably means if you get a decimal, you do want to go ahead and change it to a fraction, which Desmos is very helpful with. All right, let's take a look at question number 4. In question number 4, they are asking us to find the area of the rhombus below. This is the formula for a rhombus, and D1 and D2 are, of course, my diagonals. One thing that you do have to remember from the properties of a rhombus is that the diagonals of a rhombus bisect each other. That means that at that point V in the middle of my rhombus, the two diagonals, 1, 2, are cutting each other in half. This piece and this piece are equal. That piece and that piece are equal. All right, let's go ahead and let's label our diagonals. So this diagonal is called WY. Notice right here that they tell you that WY is equal to 28. You don't have to break it down. It is already 28. So I can already say that I'm going to plug in 28 to my formula. There we go, just getting it ready. Now my other diagonal is this one right here. Notice they tell me that XV is 10. Be careful because this is XV. But I need the whole thing to be diagonal too. This is where this property comes in. So if they only give you half, the other half is exactly the same, and your diagonal 2 is going to be 10 plus 10, or 20. All right, so what's going in the calculator? 28 times 2, 28 times 20 divided by 2, which gives me an answer of 280 centimeters squared. Always squared for the area. Don't pick the cubic. All right, let's take a look at question number 5. In question number 5, you are going to be asked you are going to be told something about a rectangle and a triangle, a right triangle. So these are the two formulas that you are going to use. You are going to use the triangle formula and you are going to use the rectangle formula. Now, the reason why I am putting the triangular formula first is because they do want us to find the area of the shaded region. So that means I'm always going to take the larger of the two figures first. Since the shaded region appears to be in this triangle, I need to put the triangle first. Then what they have done is they have taken this rectangular piece out of my triangle. Now they could do this backwards in your question. So you could have a large rectangle like this that a triangle has been taken out of, oh, probably something like this. And so this would be the shaded part, and then this one would be dashed, okay? It is a right triangle, so I'm going to go ahead and use that fact to help me out. That means there's 90-degree corners. All right. My base of my triangle would be this piece right here. Well, all I can see is the 6. But remember in my rectangle, if this is 2, this is 2. So I know that this is 2, which means my whole side here is going to be 8 centimeters. 2 plus 6. So I'm going to put in 8. The height of my triangle is going to be this right here. Once again, I need this piece. This piece and this piece are going to be equal because of the rectangle. 3 plus 3, 6 centimeters. So 1/2 times 8 times 6. Now let's take a look at our rectangle. In our rectangle, I would say this would be my base and this would be my height. And it doesn't matter. It really doesn't matter for the rectangle. So I would have 3 times 2. And I'm going to go ahead and subtract these. Well, 1/2 times 8 times 6 is 24. And 3 times 2 is 6. 24 minus 6 is 18. And they're talking area centimeters squared. Please don't pick the cubic. All right. If your larger portion that's shaded looks more like a rectangle, then you would just switch the two and do the rectangle's area minus the triangle's area. All right, question number 6 is going to ask you for the circumference of the circle. Notice it's going to tell you in the first part the diameter of the circle is 8 centimeters. Now it could tell you that the radius is 8 centimeters. And then it's going to ask you what is the circumference of the circle. There are two circumference formulas. One of them is used when you have the diameter. This is the one I'm going to use today. And then there's this one for when you are given the radius. So depending on which one you use dictates the formula that you will use. If you would like to use this one, this is the one I do have committed to my memory. You remember that the radius is half of the diameter, so you could do 1/2 times the diameter, or you can simply take the diameter and divide it by 2. I'm going to use this formula though. Notice that also Alex is asking me to use 3.14 for pi, and it is saying do not round my answer. So I'm simply going to say 3.14 times 20. I'm going to put that in a calculator, either the one in Desmos or the one that Alex provides for me, and I get this. We're talking about circumference, so it is simply centimeters. It is not centimeters squared. Don't use the cube. All right. Question number 8 is going to have a ring-shaped region like the one below. It is going to talk about its inner radius minus 14 and its outer radius minus 17. It is going to ask you to find the area of the shaded region. And once again, it is going to ask you to use 3.14 for pi. All right, and it's going to say do not round your answer. You're going to take the outer circle and you're going to find its area first. Then you're going to do the inner circle's area and you're going to subtract them. This is the outer minus the inner. All right, let's go ahead and do these. My radius for the outer was 17 squared. So I'm putting 3.14 times 17 squared into the calculator, and I get this for my decimal. And my unit, of course, would be feet squared. For the inner, I'm going to do 3.14 times my radius of 14 squared, and I get this for my decimal. And then I'm going to come over here and I'm simply going to subtract this decimal, 907.46 minus 615.44 for my final answer of 292.02 feet squared. And they're not asking me to do to pick the correct unit for this one. They've already given it to me. All right. Question number 9 is the one with the shaded portion of my circle, and it's going to ask you to find both the length and the area of the shaded region. So you are going to have to use your arc length formula and your area of your sector formula. Now be very careful. I have highlighted them so that you know that I'm going to do this one first, and then I'm going to do this one second, and which one goes with which one. These two could be switched in yours, and so then you would have to just simply switch these two as well, okay? Notice in the first sentence, they are going to give you the radius. Mine is 4 meters, so let me go ahead and add that to my picture because I didn't. And then it is going to tell me right here that the measure of AOB is 150 degrees. There is AOB, and I've added it in there. But notice the part that they're asking for, the shaded part, is this right here. So I do have to go ahead and say 360 degrees, my whole circle, minus the 150 that they gave me is equal to 210 degrees. This is what I'm going to use for the measure of arc ADB. It equals 210 degrees. There we go. All right, so here we go. 210 divided by 360 times 2 times pi times my radius of 4. Notice that it does say right here to give exact answers in terms of pi. That means that my answer has to have a fraction and it has to have the pi symbol. What's going in my calculator? This, the fraction times 2 times 4. The fraction times 2 times 4. I get for an answer. Now, I did in Desmos have to change that to a fraction. I need to put the pi symbol with it, and because this is the length, I'm going to simply use the unit of meters. So this one is going to be used when we do the length. This one is for length. Don't use the cubic. All right, I'm not going to put this in the box up there because it's going to get all hard to do. All right, for my area of my sector, I'm going to use the same 210 degrees, divide that by 360 times pi times my radius was 4 squared. What's going in my calculator? Everything but pi. The fraction times 4 squared. The fraction times 4 squared. I want to make sure that I turn my decimal into a fraction in Desmos. There we go. I put the symbol pi behind my fraction, and because we're talking area, I need to use the unit squared, meters squared. So this one is for when it says area. Don't use the cubic. All right, the last two questions are going to come from our last assignment. And question number 10 will be the easier of the two, because if you read the question, it is going to tell you, it's either going to tell you what the perimeter is, remember P stands for perimeter, and it's going to tell you what the apothem is, or at least approximate it. And then it's going to ask you to find the area. So this one is an octagon, and it does tell me that a regular octagon has a side of approximately 5 centimeters. This side is going to allow me to find P. Now, I know that since it's an octagon, it has 8 sides. So to find the perimeter, I'm going to take the number of sides and multiply it by how long each side is. And they told me it's approximately 5. I can see that right here. So 8 times 5 is 40. And my unit, of course, for this would be centimeters, but I don't really need that. They have also told me that my apothem is approximately 6 centimeters. Well, they said 6.0, but I'm just going to put it at 6. All right, now I can go ahead and plug everything into the formula. Times 6 times 40. And so I'm just going to multiply 1/2 times 6 times 40, and I get an answer of 120. Its area, so it would be centimeters squared. 120. Oh, they've already got the unit for you. Now, question number 11, the last question on the test today, is probably going to be the hardest. That's because they're going to give you a regular hexagon. They might give you a regular triangle, but we saw that in the notes. So hopefully you still have the picture of your notes to go back if you have a triangle. They are going to, well, in this one they gave me the radius. They may give you the apothem, but I did not luck out. I got the radius. They are going to ask you to write your answer in simplest radical form. That means this special right triangle is going to have a square root in it. Remember, both of my special right triangles, one had the square root of 3, one had the square root of 2. So it's going to be one of those special right triangles. A hexagon has 6 sides. So to find the central angle of this right here, I'm going to take 360 and divide it by 6, and I get 60 degrees. Now this right here is my apothem. This is my apothem, which is that purple line in the hexagon as well. All right, so if this angle is 60 degrees, when I go ahead and make the right triangle, this angle is half of 60, which makes it 30 degrees. So this angle is 30 degrees. Since I have a 30 and a 90, I know that this angle here has to be 60 degrees because 30 plus 60 plus 90 is 180. In my 30, 60, 90 triangle, I know that, and I'm going to use a pink color, I know that the short leg is here between the 60 and the 90. I know that the long leg is here between the 30 and the 90, and I know that this is the hypotenuse. I also know that the short leg is A, the long leg is A times the square root of 3, and that the hypotenuse is 2 times A. Notice right here, I have an equation, and I can solve for that pink A. This A is not the same as the A for my apothem. This is the pink A. So let me go ahead and make that a pink. There we go. There is a multiplication hiding in there, and so I'm just going to simply divide by 2, and all those pink A's, let me change this one. There we go. All those pink A's are equal to 2. So that means this is 2, which is this right here. Remember, these two are always the same. 2 plus 2 is 4. And this is important because guess what? That is going to give you the side, which helps you find your perimeter. So now I can find my perimeter, which is my number of sides times the length of each side. So 6 times 4 is 24. And of course, it would be centimeters. The last thing I need to find is my apothem. Now, my apothem is that purple shaded line, this one right here. I'm making it darker. I know that that pink A is 2, so I'm going to say it's 2 times the square root of 3. This would be 2 times the square root of 3. And of course, the bottom would be 2. All right, now I have everything I need to go ahead and find my area. I'm going to say it's 1/2 times my apothem, 2 square roots of 3, times my perimeter, which we said was 24. It asks me to give my answers in simplest radical form. That means everything but this is going into the calculator. This is kind of acting like pi does. So my answer is going to have the square root of 3, and I'm going to multiply 1/2 times 2 times 24. So I end up with an answer of 24 square root of 3 centimeters squared, because we're talking about area. Oh, it already had that in there. So this is what I would put. Good luck, you guys.